In this lesson, we'll be contrasting linear and nonlinear. By the end of the lesson, you should be able to use a table, graph, words, and equations to decide whether a relationship is linear or not, and be able to write and graph a linear relationship. So determining if it's linear. When we look at a table, we're looking for that constant rate of change. So checking the y, seeing if we can see a pattern of adding and subtracting, and same with the x. In the graph, we should have a straight line that will show us that it is linear. When you're reading words, look for that beginning amount and that amount per. So in this example, skating is $5 to rent the skates, that's the beginning amount, and $1 per hour to skate. So that's our rate of change. That's what's happening over and over. The equation should look similar to y equals 2/3 x plus 1 or y equals 3x minus 4, something in that format of y equals mx plus b. To write a linear equation, the m is the slope and the b is the y-intercept. So we're going to have to find the slope. If you have 2 points, you're going to take y2 minus y1 over x2 minus x1, or the change in y over the change in x. So for example, in this graph, the m is the slope, so we're going to count how much up and over from one point to the next. The b is the y-intercept, so where does it cross the y? And then we write our equation, y equals 2x plus 1. In a table, the m is going to be that rate of change, so what keeps happening to the y over the x, so that would be 4 in this example. The b is where x is 0, so that is 6, and we write our equation, y equals 4x plus 6. In the words here, the m is the slope or rate of change. That's the $10 per hour. The b is the $5 tip, and we write the equation y equals 10x plus 5. To graph the linear equation, we begin at the y-intercept, so we begin at this number, and we move according to the slope. So in this one, we're going to begin at 2, and we move up 1, right 3. So we begin at 2, we go up 1, right 3, up 1, right 3. So an example, the graph shows the linear relationship between the distance traveled and the time in minutes. So to write the equation, we're going to have to find the slope. So we pick 2 points, how much up, how much over. So 50 over 30 simplifies to 5/3. Then we need to find the y-intercept. Where does it cross the y? So this one comes in at 0, 0. We write our equation, y equals 5/3 x plus 0. You don't really have to put the 0, but I wanted to show you where it goes. And then if we want to find the distance at 90 minutes, we'll just go up and over, and we'll find that the distance is 150 kilometers. Write an equation for the linear representations. So from the graph, the first thing we have to do is find the slope. So choose 2 points. This is going down 20 and over 10. Remember, you have to look at the x and y intercepts to see what that change is per box. Then we find the y-intercept, so that's 140, and we write our equation, y equals negative 2x plus 140. In the table, first thing I have to do is find that slope, so the change in y over the change in x, so 8 over 2, which is 4. Then I need the y-intercept, which is where x is equal to 0. And then we write our equation, y equals 4x plus 3. So let's just take some examples here. This one, that one would be linear, and this is an example of exponential. It's not linear, it's got a curve. This one is our equation, so y equals mx plus b, and this one has an x in the exponent. So I know that it is exponential. With this one, we're looking for that constant rate. Oh, our constant rate, when it's multiply and divide, it's exponential. When we add and subtract, it's linear. So in this one, you can see that it's being multiplied by 3, so that's exponential. And this one, it's subtracting 4 on the y and 6 on the x, so it's linear. So our examples here, linear or not. So this first one, we look at the y, it's how much it's changing, and how much the x is changing. Yes, that's linear. This one, again, this curve that we have, and we have an x in the exponent as the exponent. No, that's exponential. Here, looking at the equation, you can see x in the exponent, and you can see that it's doubling. So when it's doubling, it means it's multiplied by 2. And this one, yes, because it is a straight line.